Everyone knows tractors plow fields, pull implements, and power modern agriculture. But what if I told you that tractors have reached the South Pole, that supercar manufacturers like Porsche and Lamborghini built them before building sports cars, and that the fastest tractor on Earth has exceeded 150 miles per hour? What if I told you that the term tractor didn't even exist until 1907, that barn-built machines from North Dakota farmers launched an entire industry category, and that during World War II, some tractors ran on smoke from burning wood because fuel was rationed? Today, we're counting down 27 unknown facts about tractors, from engineering breakthroughs that transformed agriculture to bizarre wartime adaptations, from speed records that seem impossible to cultural moments that made tractors viral icons. These aren't just interesting trivia, these are the stories that reveal how tractors shaped farming, survived wars, conquered Antarctica, and became far more than simple machines for working soil. This is tractor history that nobody tells, but everybody should know. Number 27, a proxy for rural health. The 27th fact takes us into economics, where tractor and implement sales function as leading indicators of farm investment cycles and broader rural economic confidence that analysts track predicting agricultural prosperity. When farmers buy new tractors, they're making substantial capital investments, signaling confidence about future crop prices, land values, and profitability that justify spending hundreds of thousands of dollars on equipment that won't generate returns for years. The purchases reflect optimism about agricultural markets and willingness to take on debt or spend savings on assets that will depreciate but that are necessary for maintaining competitive productivity. The correlation between tractor sales and rural economic health is strong enough that economists, agricultural lenders, and equipment manufacturers watch sales data closely as a barometer of conditions in farming communities, where equipment purchases represent discretionary spending that farmers defer during uncertain times but accelerate when conditions improve. The data provides early warning of downturns when sales decline suddenly, or confirmation of recoveries when purchases resume after periods of restraint during which farmers may do with aging equipment rather than investing in replacements or upgrades. Number 26, steel lugs versus paved roads. Early tractors equipped with steel lugs that provided excellent traction in fields, but tore up pavement prompted road restrictions and accelerated adoption of rubber tires, representing not just comfort improvement, but legal necessity for farmers needing to transport equipment on public roads. The steel lugs featured aggressive cleats that dug into soil, creating the grip necessary for pulling heavy loads through muddy or loose conditions where smooth wheels would spin uselessly. But those same cleats damaged pavement by concentrating tractor weight onto small contact points that crushed asphalt or concrete. The road damage became serious enough that many jurisdictions banned steel lug tractors from paved roads or imposed restrictions limiting speeds and routes that could be used, creating inconvenience for farmers who needed to move equipment between fields or transport tractors to repair shops. The restrictions provided additional motivation beyond operator comfort for adopting pneumatic rubber tires that became available in the mid-1930s, and that transformed tractor operation by providing adequate traction while protecting road surfaces and allowing higher transport speeds than steel lugs could safely achieve. Number 25, hydraulics got smarter. Closed-center load-sensing hydraulics allow precise, efficient power delivery to multiple implements simultaneously, minimizing wasted energy compared to older open-center systems that continuously circulated hydraulic fluid regardless of whether implements required power. The closed-center systems keep pumps idle until implements demand flow, then deliver exactly the pressure and volume needed, rather than constantly running pumps at maximum output and bleeding excess flow through relief valves that wasted energy, heating hydraulic oil without performing useful work. The efficiency gains are substantial, with modern tractors consuming significantly less fuel, operating hydraulically intensive implements compared to older designs, where hydraulic systems represented parasitic loads, reducing available engine power and increasing fuel consumption. The load sensing technology uses pressure sensors, monitoring system demands, and varying pump output matching requirements precisely, creating responsiveness that allows operating multiple implements with independent control while maintaining adequate flow and pressure for each function without the compromises that fixed displacement pumps imposed. Number 24, start on gas, run on kerosene. Many mid-20th century tractors used distillate or kerosene fuel, starting on gasoline with a hot intake manifold, providing heat necessary for vaporizing the heavier fuel, then switching to cheaper kerosene once the engine reached operating temperature. The dual fuel systems featured small gasoline tanks, providing enough fuel for starting and warm-up lasting several minutes, plus larger main tanks holding kerosene or distillate. That was substantially cheaper than gasoline, but that wouldn't vaporize adequately in cold engines requiring initial operation on more volatile gasoline. The manifold heating came from exhaust gases routed through passages, warming intake air and fuel mixture to temperatures where kerosene would vaporize properly and burn completely rather than condensing and washing oil from cylinder walls or passing through combustion chambers without igniting. The system saved farmers money by allowing use of cheaper fuel for hours of daily operation after brief gasoline startup periods, consuming minimal expensive fuel, creating operating cost advantages that justified the complexity of dual fuel systems and the procedures required for proper switching between fuels. Number 23, plug-and-play implements. ISOBUS and modern electronics let tractors communicate with implements, including planters and sprayers, for automatic section control, variable rate application, and simplified setup that older systems required manual adjustment achieving. The standardized communication protocol allows implements from any manufacturer to interface with tractors from different brands, eliminating proprietary systems that locked farmers into single-brand ecosystems, where implements and tractors had to match or require expensive adapters and modifications enabling compatibility. The automatic functions include section control that shuts off individual planter rows or sprayer nozzles when GPS detects overlap with previously covered areas, preventing double application wasting seed or chemicals, while creating crop damage from excessive rates. The variable rate capability adjusts application rates automatically based on prescription maps created from soil sampling or yield monitoring, delivering more inputs where soil quality or historical productivity justifies increased investment, and reducing applications where conditions don't support higher rates. Number 22, comfort became a productivity feature. By the 1970s and 80s, tractor cabs added HVAC systems, suspension seats, and noise insulation, making long days safer and far less punishing, while improving operator performance through reduced fatigue. The recognition that comfortable operators worked more efficiently and made better decisions transformed cab design from basic weather protection into sophisticated environments, where temperature, noise, vibration, and ergonomics were carefully engineered, creating workspaces rivaling automobiles in comfort and exceeding them in visibility and functionality. The suspension seats isolated operators from jolts and vibrations transmitted through the chassis, reducing back pain and fatigue that accumulated during 12-hour days operating on rough fields. The climate control maintained comfortable temperatures regardless of external conditions, preventing heat exhaustion during summer and cold-related discomfort during spring and fall when temperatures were marginal. The sound insulation reduced noise levels, protecting hearing, while allowing operators to detect abnormal sounds, indicating mechanical problems requiring attention before minor issues became major failures. The visibility improvements from larger windows and strategically positioned mirrors allowed operators to monitor implements and surroundings without constantly turning their bodies or craning necks, reducing the muscle strain and stiffness that came from maintaining awkward positions throughout long workdays. The ergonomic controls positioned within natural reach reduced the repetitive motion injuries that plagued operators of earlier tractors, where levers and pedals required excessive force or uncomfortable stretching that accumulated stress on joints and tendons over thousands of hours of operation. The air filtration systems removed dust and chaff that older open-station tractors exposed operators to constantly, eliminating the respiratory irritation and long-term lung damage that agricultural dust created when breathed continuously during entire careers spent operating equipment in dusty field conditions. The overall result was that operators could work longer hours more safely and effectively, maintaining concentration and making better decisions about implement adjustments, field conditions, and equipment operation, because they weren't distracted by physical discomfort that earlier tractors imposed as an unavoidable cost of operating agricultural equipment. Number 21, diesel wins the farm. Post-World War II, diesel engines dominated agricultural equipment for their torque and fuel economy, with gasoline remaining mainly in small utility and lawn tractors where diesel's advantages didn't justify higher initial costs. The diesel's efficiency came from higher compression ratios, extracting more energy from fuel and from combustion characteristics that allowed running leaner mixtures than gasoline engines could manage without detonation or incomplete combustion, creating power losses and emissions. The torque characteristics suited agricultural work perfectly, with diesels producing maximum torque at relatively low RPM, where tractors operated most efficiently, unlike gasoline engines requiring higher speeds achieving peak output. The fuel economy advantages accumulated dramatically over thousands of annual operating hours, with diesels consuming 30 to 40% less fuel than equivalent gasoline engines, saving thousands of dollars annually on large operations where fuel represented a major operating expense. Number 20. Tractor pulling's roots. The sport of tractor pulling evolved from early horsepower contests, where farmers proved whose machine could drag the heaviest sled, eventually standardizing weighted sleds and classes, creating organized competition. The informal competitions began at agricultural fairs and community gatherings, where farmers would hitch tractors to sleds loaded with weights and see whose machine could pull furthest before losing traction or stalling, with bragging rights going to winners demonstrating superior power, traction, or driver skill. The spectacle attracted crowds who appreciated seeing working machines pushed to their absolute limits, creating entertainment that celebrated agricultural power and mechanical prowess in ways that connected directly to the daily challenges that farming communities understood through their own experience operating equipment. The evolution required establishing rules, preventing dangerous modifications, and ensuring fair competition, with organizers creating weight classes based on tractor size and distinguishing between stock tractors that farmers actually used for fieldwork and modified machines built specifically for competition with turbocharged engines and specialized drivetrains. The modern pulling sleds became sophisticated with weight transfer systems that used movable weights sliding forward as sleds were pulled, progressively increasing resistance until even 1,000-horsepower machines would spin their wheels and stall after predetermined distances that tested maximum capability rather than just comparing raw power specifications. The cultural significance extended beyond entertainment, with tractor pulls becoming social events where farming communities gathered celebrating agricultural heritage, while manufacturers used competitions showcasing equipment durability and power that translated into marketing advantages when farmers recognized brands dominating pulling circuits as evidence of engineering excellence and mechanical superiority. The evolution into organized sport required standardizing weights, distances, and tractor classifications, preventing unlimited modifications that would make competition meaningless, as purpose-built machines overwhelmed stock tractors that working farmers could relate to and afford. The modern pulling sleds use weight transfer systems that progressively load the front of sleds as they're pulled, creating increasing resistance that eventually stops even the most powerful tractors after predetermined distances, where all competitors face equal challenges testing power and traction, rather than just comparing raw horsepower ratings. Number 19. Walking tractors feed millions. Two-wheel walk-behind tractors power smallholder farms across Asia and Africa, plowing rice paddies, driving threshers, and transporting goods on minimal fuel, while providing mechanization to farmers who could never afford conventional four-wheel tractors. The compact designs feature single-cylinder diesel engines producing 8 to 15 horsepower through simple, robust construction that farmers can maintain with basic tools and minimal technical knowledge, creating accessibility that conventional tractors can't match in regions where capital is limited and where infrastructure doesn't support sophisticated equipment. The versatility comes from power takeoff systems, driving various implements from the same engine, with farmers using walking tractors for plowing during land preparation, for powering threshers during harvest, and for pulling carts during transport, creating multi-purpose machines that justify purchase costs through year-round utilization. The fuel economy is exceptional, with engines consuming less than 1 gallon daily during typical operation, making them affordable to run even for subsistence farmers operating on minimal cash incomes, where fuel costs must be carefully managed. Number 18. From drawbar to integrated systems. Early tractors pulled everything from drawbars, creating simple connections that worked, but that required manual implement raising and that provided no depth control, while three-point hitches and live hydraulics transformed implements into actively controlled tools. The drawbar pulling meant implements followed ground contours passively with working depth, varying based on soil resistance and implement design, requiring frequent stops for manual adjustments, maintaining proper depth as conditions changed across fields, with varying soil types and moisture levels. The three-point hitch revolutionized implement control by allowing hydraulic raising and lowering plus draft control, automatically adjusting hitch position based on resistance sensed through lower links, creating semi-automatic depth control that maintained consistent working depth, regardless of soil variations. The live hydraulics provided power even when tractors were stopped or moving slowly, unlike earlier systems requiring forward motion, activating ground-driven pumps that couldn't operate implements while stationary. Number 17, ROPS, saved countless lives. Rollover. Protective structures paired with seatbelts dramatically reduced fatal overturns once widely adopted, with retrofitting older tractors remaining crucial safety effort, preventing deaths that continue occurring on equipment lacking protection. The statistics were grim before ROPS became standard, with rollover being leading cause of tractor-related fatalities, accounting for over half of deaths occurring when tractors tipped sideways or backwards, crushing operators who were ejected or who couldn't escape before thousands of pounds landed on them. The ROPS frames create protected zones around operator stations, with steel structures designed to absorb rollover impacts, while maintaining space preventing crushing, with seatbelts keeping operators within protected zones rather than being thrown clear and then crushed as tractors complete rolls. The retrofit programs offer subsidies encouraging farmers to install ROPS on older tractors manufactured without protection, acknowledging that thousands of dangerous tractors remain in service and that preventing deaths justifies public investment in safety improvements that farmers might not afford independently. Number 16, sub-inch guidance. Modern RTK GPS, or real-time kinematic global positioning system. Guidance lets tractors drive with sub-inch repeatable accuracy, enabling precision planting, controlled traffic farming, and major input savings that older guidance methods couldn't achieve. The centimeter-level accuracy comes from correction signals, broadcast from base stations to tractor receivers, eliminating errors that standard GPS accumulates from atmospheric interference and satellite geometry, creating position uncertainties of several feet, rather than the sub-inch precision that RTK provides. The precision enables controlled traffic farming where tractors follow identical paths season after season, concentrating soil compaction in permanent lanes while leaving crop zones undisturbed by wheel traffic that reduces yields through compaction, restricting root growth, and water infiltration. The planting precision ensures rows align perfectly with previous operations, allowing cultivation equipment to work between rows without damaging plants, and enabling harvest equipment to follow planting rows, exactly maximizing grain capture and minimizing losses. Number 15, unexpected wartime icons. In 2022, videos of farmers towing abandoned armored vehicles with ordinary tractors went viral, highlighting machines' raw torque and cultural symbolism as tools of peaceful production, reclaiming instruments of destruction. The images resonated globally as metaphors for resilience and agricultural strength, with simple farm equipment effortlessly moving military hardware that seemed far more powerful but that couldn't match tractor pulling capacity, designed for moving implements and loads that military vehicles weren't engineered to handle. The torque advantages come from gearing and weight-creating traction that armored vehicles lack when disabled or out of fuel, with tractors using low-range transmissions and massive rear tires generating pulling force exceeding their engine horsepower through mechanical advantage that military vehicles trading off for speed and maneuverability don't possess. The cultural impact was substantial, with tractors becoming symbols of agricultural perseverance and ordinary people's defiance, creating memes and commentary about the power of simple tools designed for cultivation rather than combat. Number 14, fastest tractor on Earth. JCB's Fast Track. 2 set the official tractor speed record in 2019 at over 150 miles per hour using aerodynamic modifications and a highly tuned engine, while retaining fundamental tractor characteristics, including working 3-point hitch and PTO. The achievement required substantial engineering with modified Fast Track, featuring streamlined bodywork, reducing drag, upgraded suspension handling, high-speed stability, and engine modifications, increasing output beyond stock specifications, while maintaining enough tractor functionality that records officials certified it as genuine tractor rather than as purpose-built vehicle merely resembling agricultural equipment. The speed represented a tenfold increase over typical tractor operating speeds and demonstrated that agricultural equipment could achieve performance rivaling sports cars when engineering focused on maximum velocity rather than pulling capacity and fuel economy that normal tractor design prioritizes. The publicity generated by the record attempt benefited JCB by showcasing engineering capabilities and brand performance, while entertaining audiences seeing agricultural equipment performing in ways that seemed impossible for machines designed for fieldwork rather than for speed. Number 13, a Soviet export powerhouse. Belarus, MTZ tractors from Minsk became ubiquitous across Eastern Europe, Africa, and Asia, known for simplicity, affordability, and easy field repairs, making them accessible to farmers in developing regions where sophisticated equipment couldn't be supported. The designs emphasized ruggedness over refinement with mechanical simplicity, allowing repairs using basic tools and locally available parts, rather than requiring dealer service and imported components that sophisticated Western tractors depended on for maintenance and repair. The export success came from pricing substantially below Western competitors, while providing adequate capability for most farming operations, creating a value proposition that cash-strapped farmers in developing nations appreciated when equipment purchases represented major investments requiring careful justification. The durability proved exceptional, with Belarus tractors accumulating decades of service under harsh conditions where maintenance was deferred and where operating environments included extreme temperatures, poor fuel quality, and rough handling that would destroy lesser machines. Number 12, wood gas. During fuel shortages. In World War II-era Europe, some tractors were converted to run on producer gas from charcoal or wood due to fuel rationing, creating smoky, low-power but functional workaround keeping agriculture operating when conventional fuel was unavailable. The wood gasification systems used heat-converting solid fuel into flammable gas through incomplete combustion in sealed chambers, with the resulting gas mixture containing carbon monoxide, hydrogen, and other combustibles that could power internal combustion engines, despite having lower energy density than gasoline or diesel. The power losses were substantial, with wood gas providing perhaps 60% of the output that liquid fuels delivered, but the trade-off allowed continued operation when alternatives didn't exist, and when food production was critical for sustaining civilian populations and military forces during wartime, when fuel supplies were prioritized for military vehicles and essential transport. The systems were crude with bulky gasifiers, mounted on tractors, creating awkward proportions and requiring frequent refueling, plus regular cleaning, removing ash and tar accumulation that would clog systems and reduce already limited performance. Number 11, tractors at the South Pole. Sir Edmund Hillary's Antarctic expedition in 1958 used modified Fordson TE-20 tractors, hauling supplies across the frozen continent, becoming the first overland vehicles reaching the South Pole and proving agricultural equipment could function in extreme conditions. The modifications included track systems, replacing wheels for better flotation on snow, enclosed cabs protecting operators from temperatures reaching -40 degrees, and heaters preventing fuel gelling and maintaining battery capacity that cold would otherwise destroy, making starting impossible. The achievement demonstrated tractor versatility and reliability in an environment about as far from agricultural fields as possible, with machines designed for temperate farming conditions proving capable of Antarctic service after relatively modest modifications. The publicity was substantial, with tractors featured in expedition documentation and news coverage, creating association between Ferguson brand and extreme condition reliability that benefited marketing efforts, even though Antarctic expeditions weren't target market for companies selling to farmers working conventional cropland. Number 10, Supercar brands made tractors. Porsche produced elegant diesel tractors in the 1950s, and Lamborghini started as a tractor manufacturer after World War II, before moving into sports cars following founder Ferruccio Lamborghini's dispute with Enzo Ferrari. The Porsche tractors featured sophisticated engineering with air-cooled diesel engines and streamlined styling that was unusual for agricultural equipment, typically emphasizing function over form, creating distinctive appearance that made Porsche tractors recognizable and that contributed to the brand's reputation for engineering excellence, extending beyond automotive applications. The Lamborghini story began with Ferruccio building tractors using surplus military diesel engines and simple, robust designs that Italian farmers appreciated for reliability and affordability during post-war reconstruction when agriculture was mechanizing rapidly, but capital was scarce. The success made Lamborghini wealthy enough to pursue his passion for sports cars, initially as Ferrari customer, but eventually as competitor after disputes about Ferrari product quality led Ferruccio to believe he could build better vehicles than Ferrari was producing for wealthy clients like himself. Number 9. Barn-built giants. Steiger's articulated four-wheel drive tractors began in a North Dakota barn in the late 1950s when farmers Douglas and Morris Steiger built their own high-horsepower machines, kickstarting the entire category of super tractors that manufacturers would eventually offer commercially. The brothers recognized that available tractors lacked power for efficiently working the large fields that characterized Great Plains agriculture, where section-mile-long rows were common and where productivity demanded machines capable of pulling wide implements at speeds that smaller tractors couldn't maintain. The articulated design featured two separate frame sections, joined by hydraulic cylinders, providing steering through bending tractors rather than through front wheels turning on kingpins, creating configuration that distributed weight evenly across all four drive wheels while allowing tight turning radius despite substantial length. The success led to commercial production, with Steiger manufacturing building customs tractors for farmers sharing similar needs, eventually growing into a major manufacturer that Case International Harvester would acquire, incorporating Steiger designs into their product lines. Number 8. World's biggest farm tractor. The Big Bud 1647 built in Montana in 1977 remains the largest farm tractor ever made, featuring a 16-cylinder engine producing over 1,100 horsepower, designed for pulling enormous cultivators across vast acreage. The specifications were staggering, with engine displacing over 24 liters through V configuration that smoothed power delivery and provided output exceeding most semi-truck engines, creating agricultural equipment that rivaled locomotives in power, while remaining maneuverable enough for field work, rather than being limited to rail transport that actual locomotives required. The 8 drive wheels used custom tires, standing taller than adult humans, with widths measured in feet rather than inches, distributing 100,000-pound weight across surface area, preventing soil compaction that would damage productivity despite the tractor's massive mass. The cab was spacious and elevated, providing visibility across implements that could span 40 feet or more in width, creating a command center appearance that reflected the machine's capabilities and the scale of operations that justified building such extreme equipment when conventional tractors would have required multiple machines achieving same acreage coverage. Number 7. The hot bulb legend. Lanz Bulldog tractors used simple single-cylinder hot bulb engines that ran on heavy oils and that were so rugged many could be repaired with basic tools and kept working for decades, serving farmers who valued reliability over sophistication. The hot bulb ignition used engine compression heating air in the combustion chamber until it ignited fuel sprayed into hot zones, eliminating spark plugs and electrical systems that could fail and that required maintenance that made field conditions difficult. The single cylinder displaced enormous volume, producing torque through sheer size rather than through high RPM operation that multi-cylinder engines used, achieving similar output, creating distinctive sound and vibration that made Bulldogs instantly recognizable, and that owners appreciated as character rather than as deficiency compared to smoother-running multi-cylinder tractors. The simplicity meant repairs were straightforward, with worn components being easily replaced, and with design allowing operation even when parts were worn beyond specifications that would disable more sophisticated engines, requiring precision clearances and tolerances. Number 6. Rubber tires equal massive gains. The shift from steel lugs to pneumatic rubber tires in the mid-1930s boosted field speeds, reduced vibration, and cut fuel consumption, creating immediate productivity jumps that farmers recognized and that accelerated adoption once benefits became apparent. The pneumatic tires provided cushioning that steel couldn't match, absorbing jolts from rough ground and creating more comfortable operation that reduced operator fatigue while protecting tractor components from shock loads that steel wheels transmitted directly into frames and drivetrains. The traction characteristics were different, with rubber gripping soil through large contact patches rather than through steel cleats digging in, providing adequate grip for most conditions while reducing soil compaction and allowing higher speeds during transport between fields. The fuel economy improved because rolling resistance decreased dramatically compared to steel wheels that required substantial force overcoming friction and ground penetration that rubber's larger contact patches minimized. Number 5. Standard PTO speeds. Power takeoff shafts were standardized at 540 RPM and later 1000 RPM, creating a universal interface allowing implements from different manufacturers to work across tractor brands that previously used proprietary speeds and connections. The standardization eliminated confusion and incompatibility that had plagued earlier agricultural equipment, where implements designed for one tractor brand couldn't connect to competitors' machines without adapters or modifications that were expensive, and that limited farmers' flexibility choosing equipment. The 540 RPM standard was established first for general implements, including mowers, balers, and most powered equipment, while 1000 RPM was added later for implements, including rotary cutters and equipment requiring higher speeds for optimal operation. The dual standards accommodated different implement requirements while maintaining compatibility that allowed farmers mixing brands based on price, availability, and features, rather than being locked into single manufacturers because implements wouldn't connect to tractors from different brands. Number 4. The hitch that changed everything. Harry Ferguson's 3-point hitch with draft control, debuting on Ford 9N in 1939, transformed tractors into integrated systems, making implements safer, more efficient, and far easier to control than drawbar pulled equipment that had defined previous agricultural practice. The 3-point design connected implements at 3 locations, 2 lower links plus top link, creating stable mounting that prevented implements from swaying or bouncing, while allowing controlled raising and lowering through hydraulic power that eliminated manual cranking that earlier systems required. The draft control sensed resistance through lower links and automatically adjusted hitch height, maintaining consistent implement depth regardless of soil resistance changes, creating semi-automatic operation that improved work quality while reducing operator workload. The significance was profound, with Ferguson's system becoming the industry standard that all manufacturers eventually adopted because farmers demanded the convenience and performance that 3-point hitches provided over older drawbar systems that couldn't match the control and integration that Ferguson's innovation delivered. Number 3. The Fordson price shock. Henry Ford's mass-produced Fordson Model F slashed prices and flooded the market in 1917, accelerating the decline of draft horses and reshaping global agriculture through affordability that made mechanization accessible to farmers who previously couldn't justify tractor costs. The Fordson pricing was revolutionary at under $400, when competitors charged over $1,000 for tractors providing similar capability, creating a value proposition that farmers recognized immediately and that drove sales to levels that transformed Ford into an agricultural equipment powerhouse rivaling established manufacturers. The economies of scale came from automotive-style production, applying assembly line techniques to tractor manufacturing, reducing labor costs, and achieving efficiencies that small-volume agricultural equipment builders couldn't match. The impact extended globally, with Fordson exports, mechanizing agriculture across Europe and other regions, where horses remained primary power source and where Fordson's affordability finally made mechanization economically viable for typical farmers, rather than just for wealthy estate operators who could afford expensive equipment. Number 2. Who coined tractor? The term tractor was popularized in the United States by Hart Parr around 1907 to distinguish internal combustion traction engines from steam machines, helping define the modern category and creating terminology that would become universal describing agricultural power equipment. Before Hart Parr's marketing established tractor as a standard term, agricultural power equipment was called various names, including gasoline traction engine or oil traction engine, or simply power farming machine, creating confusion and preventing establishment of category identity that would help farmers and manufacturers communicate about equipment. The Hart Parr contribution was recognizing that new technology deserved a distinctive name, rather than being defined by comparison to steam engines that had dominated agricultural power for previous decades. The tractor terminology caught on quickly because it was simple, memorable, and clearly distinguished internal combustion equipment from steam predecessors that were rapidly becoming obsolete as gasoline and later diesel engines proved more practical for typical farming operations, where steam's complexity and water requirements created operational challenges that internal combustion eliminated. Number 1. Origin of the gasoline tractor. John Froelich built and successfully operated the first gasoline-powered tractor in Iowa in 1892, moving away from cumbersome steam traction engines and proving internal combustion was viable for farm work that would transform agriculture from animal power to mechanical power. The achievement represented a breakthrough moment when technology that had been developed for stationary engines and early automobiles was successfully adapted for agricultural pulling, requiring sustained power under varying loads that would challenge engine and drivetrain durability in ways that previous applications hadn't demanded. The significance was that Froelich proved gasoline engines could provide reliable power for extended operation rather than failing under sustained loads that farming imposed, overcoming skepticism that internal combustion was too delicate or unreliable for serious agricultural work that steam engines had been handling for decades. The success wasn't immediate, with decades passing before gasoline and diesel tractors would completely replace steam, but Froelich's demonstration established that path forward existed and that internal combustion represented the future of agricultural power, rather than being curiosity unsuited for demanding farm applications. These 27 facts prove that tractor history extends far beyond simple evolution from horses to machines, encompassing innovations that revolutionized farming, adaptations that allowed operations in conditions from Antarctic ice to war-torn Europe, and cultural moments that made tractors viral icons representing agricultural resilience. From John Froelich's pioneering gasoline tractor to modern GPS guidance achieving sub-inch accuracy, from barn-built giants to factory speed records, tractors have been at the center of agricultural transformation, global conflicts, polar exploration, and countless innovations that shaped how food is produced and how rural communities function. Which facts surprised you most? Share your thoughts below. Subscribe now. More agricultural history and tractor stories coming soon.